remember, we have questioning the process of optimization with Wallis and Galapagos because our focus was on the form, and we figure out that these plugins or any other plugin, any other optimization plugin, or even optimization algorithms, they do not care about form as much as we need. So they just understand the numbers, the fitness function values. We ask you to think about it and to see if you can find a way to control the form as long as we are optimizing the performance. Now, if there's any question, I will be more than happy to answer. And if there's not, let's go forward to the Giraffe team and see what they bring for us. Okay, let me check the chat. Hi, hello, Saper, hello, Mohammed. Welcome. And we are waiting for the uh, Giraffe team to see. And hello, Anjum, nice to see you here. Hi, Vira, hi. Okay, we are waiting for Gilva. She's going to present a presentation about different plots, about Matplotlib, how we draw chart and plots there, and how we customize those chart and plots in Giraffe plugin and draw them in the Grasshopper. And also will explain a bit about what of these chart is, what is a scatter plot, what is a heat map, what is line plot, and how we work with 2D plot, 3D plot, and these sort of things. And then I guess Martin, if you're here now, will introduce the plugin itself, introduce the plugin in Grasshopper, will explain about different components we have and we're going to have, of course, in our development process. And then the other GF teams, they use the Giraffe plugin in their different projects. We have optimization projects, mostly on energy optimization. We have some class projects, like on their class, university class projects. And also we have some special projects that, because some of the Giraffe teams, they're running their own business, and it is not exactly an architectural design business, but they use Giraffe. That's how widespread our plugin hopefully will be. So, Gilva, can you hear my voice? Yeah, yeah.
Hi everyone. Yeah, hi Ghazal.
Hi, thank you for today. Thank you from you and all the Giraffe teams. So we are waiting for.
Yeah, definitely. I'm going to share my screen. Okay. Actually, host disabled participants is screen sharing. Would you please just change the settings?
Sure, sure, sorry. I will change this setting as soon as I figure out how. So in the more, I do not have any in the participants. Let's see. If anyone can guide me where I can do that, that will make it faster for me. Let me see. Know there should be a panel for participants here. I just can't find it right now to give the
It's down
participant.
there. If you can see it, it's right next to the chat down here.
Yeah, yeah, yeah. I found it. It's in the host tools. Yes, and now I enable share screen by all of and even record computer. That's a good option. I enable that too. So now everyone can share its screen and record the record the Zoom video into their computers. Okay, all set.
Thank you. Okay, everyone. I'm gonna close my camera and I will share my screen. So, here it is. Okay. Welcome everyone. I'm honored to introduce the Giraffe plugin in this workshop today. So we have a table of contents that first we're going to start with the introduction of the Matplotlib, then we're going directly next to the Giraffe introduction, and then I'm going to explain most of the plots, which are kind of trendy ones that we're using the most, such as scattered 2D and 3D plots, line plot, bar plot, pie plot, heat map, histogram, and surface 3D, and also showing you both on the Matplotlib websites, and also showing you the image of the plugin and inputs, outputs, and how it worked actually. So for beginning, we have the introduction of the Matplotlib. Okay. You gotta ask that what is Matplotlib? So it's a comprehensive and flexible library for creating static, animated, and introductive visualization in Python. It's widely used in scientific, engineering, and data analysis communities. And since its creation on 2003, it's become the standard tool for data visualization in Python. So it's kind of user-friendly, and most of the people who are working with the data are definitely working with the Matplotlib also. So it just offers several advantages, like its powerful nature, wide range of plotting capabilities, and a high level of customization. And also it integrates well with the other scientific libraries such as NumPy and Pandas. So for this moment, I'm just leading you to the website of the Matplotlib, which is matplotlib.org, that you can check most of the plots here. We have a tab here, its name is plot types. So here are the plots that we're also working on for the plugin. So we have the line plot, the scatter one, bar, stem, and by scrolling down, you can also see the wide range of the plots here. And we've been trying to add the most trendy ones into the plugin actually. So here we have also the example toolbar that you can check most of the different things with the examples just for understanding and recognizing how it works and how you can use each of these data by the different kind of the examples. For your designs, something like this. Okay, by going back to this one, I'm going to give you a little introduction about the NumPy and Pandas, because maybe you got to ask that, what is it that actually Matplotlib interacts with these two very well. So NumPy actually it brings a sort of numerical Python. It's a kind of fundamental library for numerical computing, and it provides arrays, matrices, and wide range of mathematical functions. And in addition, Pandas is also another library for the Python that gonna be used for the data manipulation. And whenever you want to use the wide range of the numbers, which you need to be set randomly, you can use Pandas and NumPy. So we're going directly to the Giraffe. So we're so happy and honored to introduce the Giraffe, actually the Matplotlib integration for the Grasshopper. So the Giraffe plugin integrates the powerful plotting capabilities of Matplotlib directly to the Grasshopper, and it's enabling the visualization of data and design outputs within Rhino's computational design environment. So this plugin offers a range of chart types, including line plots, that we use the line plots for the visualizing the trends and patterns. The scatter ones that we use for exploring the relationships between variables, bar charts for comparing categorical data, and stem plots for visualizing categorical data. So we have some key points and key features here for the Giraffe plugin, including dynamic interactive plots that you can use most of the plots, and having the output just as you like. You can customize them by having different features such as choosing the markers, choosing the colors, etc. And we have two types of the plots, 2D and 3D, that you can use as based on your needs. And it's a kind of open source that you can click and buy on the icon of the component. You can look at the Python scripting, and it's totally user-friendly. So the first one that I'm going to talk about is the scatter plot that actually displays the values of typically two variables, and each of the points represents an observation. The picture that you're seeing here is just the icon for the scatter plot in the Matplotlib website, and this one is actually the picture of the component in the Grasshopper, but in the next steps that the other members of the Giraffe plugin are gonna represent the different components of the plugin. You may understand or you may recognize a different change with the inputs or even the icons, but just for showing you the progress and explain that most of the things change during the time, and no worries. So we have the scatter plot. This one is the 2D. We have the inputs that you can your data to. We have the size, color, and different criteria that which are all explained here, and we can go by. So this one is the line plot that actually displays data points on a line and shows changes over time and other continuous variables. And it's actually used for analyzing the trends and changes over time and comparing data. This one is the component that we have the data's input data's labels, color, width, and line style. That you can customize it as whatever you like, and you can choose the label, the color. We have 12 colors. You can choose the width, and the line style gotta be just dashed lines, continuous lines, dotted lines, and etc. The next one is the bar plot. That bar plot displays rectangular bars, and by different heights, it actually shows the value of the each represents, and it's used for comparing the different categories. And this one is also the component. We have also here the datas, a label, color, and width. So the next one is the pie plot. It's a kind of circular statistical graphic that divide each of the categories into different slices and illustrate the numerical proportions. So you can also use it here. Yeah, actually, I wanted to mention the donuts one actually, that you can have a input and choose the radius and just making a hole here and just change it into the donuts one. So you have the colors, radius, labels, you can choose the distance, And the next one is the heat map. It's a data visualization technique that shows the magnitude of a phenomenon as color in 2 dimensions. And it's using for displaying the correlation between variables and visualizing data in matrix form. Here is the component in the Grasshopper. So we have different inputs, data tree, labels, color, and categories that each of these have the different types, such as a string and etc. The next one is histogram. It's a bar graph that organizes the data points and shows the distribution of a data set. So we can use it for analyzing the distribution of data and identifying outliers in data. So this one is the component, and you can customize it as you like, just like the previous components. And input of the data for each of these components are kind of different, that if you put your math on it, it's gonna show and represent the whole the whole explanation of the everything. So we have the color, line width, bins, and data here. So we're going to the 3D plots that we have 3D scatter plot. Whatever you're gonna have in the 2D plots, you can have it in the 3D plots by just having the 3D dimension view. And this one is the view of the component. We have the Z dimension also here. You can choose the markers, you can choose the color, size, labels, everything as you prefer. This one is the 3D line plot that used to represent data points, just like in the 2D line plot, but you can have it in the 3D point of view, in 3D spaces actually. And here are the different options, just like the previous ones, and 3D surface plot. And actually, this one shows the surface that has a solid edges and solid faces, and representing the topography and surface data. And this one is also the picture of the component. So to have a conclusion about the giraffe, is just a powerful tool for visualization in Python, and it offers a wide range of plotting capabilities. You can use it just as you like, and you can have it exactly at the moment while you're designing or trying to working on some data, some tables, and you can just have the conclusion just next to your designs. And we think that is just a great opportunity to work and having everything all together.
Thank you. Thank you so much, Gilva. It was a good explanation and presentation.
Thank you.
Thank you. Thank you for comparing every components with the Matplotlib plots. You know, Matplotlib is a library in Python, and if you work with Python, it is so famous. So I would be, I'm sure that if you work with Python, you hear about Matplotlib or at least work with that once. But if you don't know, this is something very more complete in compared to Excel. You know, we can draw plots and some charts in Excel. Matplotlib is a very complete version of drawing charts and plots compared to Excel. And yes, we try to customize the same plots in the Grasshopper with by writing giraffe. So after the Gilva presentation, we can have Mateen to explain the exact components in the Grasshopper. So, hello,
Hi.
Mateen.
Can you see me? Can you hear me? Everything's
Yes,
okay?
thank Everything is clear.
All right. So as you said, we took the library on Python and we made it available inside Grasshopper. So if you are not a heavy coder and you don't want to get into weeds of making your own components, there's a component ready for you, so you can easily and in a fast fashion way get to the point and take what you need and don't fuss with coding and learning Python. So you have a smaller feedback loop. You don't have to export your data and get your data back and start seeing what conditions are there and whatnot. So you can do your job faster and it's easier for you. And let's see what we got here. I'm sharing my screen. I'm hoping you can see a Grasshopper screen. Everything's all right?
Well, I think it's. Oh, yes. Yes, now I can see it. Thank you.
Okay. I think there's a delay, right?
Yes, exactly. There's a bit of delay, but it's okay
Okay.
with me.
I try to speak a bit slowly so the delay doesn't mess with the presentation, but we got time and a deadline. So there are a few plots and there's a category for each of them. So here you can see there's a bunch of plots here, and we have a category here. It is a utility, and you take the plots you make here, you feed them to a utility here called a, let me see, plot, and when you connect these two together, you create a bitmap. You need to preview that bitmap or have it exported. So for that, we use Javid, which is a plugin for working with bitmap. If you don't have it, you can download it from Food for Rhino and say preview bitmap. And then you have a bitmap that is easily made from the data you've just created. So let's go back and start from the beginning. This is a scattered 2D, so as you may think, you would give it x and y, but we opted for points because this is Grasshopper, and we already have a complete pipeline for making geometry. So if we make a geometry, we can visualize it in Grasshopper with the tools that Grasshopper provides for us. And we can use other tools that do not make x and y coordinates, like here. This is a populate 2D, and it creates a bunch of points. It's right here. And this bunch of points, and are completely random because they're made from a random component, and they're fed into this. And let's see it here. This is a filter, and it filters by this number. So 0 is the first graph up here, and we're going to go through this and see how they look and how they function. So this is the only plot component. You make your components with this, and you feed it to the plot, just as I said. And there's the properties and a view, and you don't need to mess with view and it's a 2D plot, but you will need to mess with view if it's a 3D. But for now, we're not going to talk about that. So there's plottable, view, and properties. And properties are populated here. We're going to talk about it later. Let's go back here and see what properties does the plottable maker, this component that makes this plottable output for us, have. Well, the points we talked about. The next one is the size of the markers we put on the canvas here. And you can see these are about 100 units, and you can increase them to an ungodly amount until they start overlapping each other. There's no guardrails, so it's completely user interactive and user oriented, but it gives you the ability to mess up some things, and you're gonna see some of that happening with pie chart or things like that. So you need to be wary of what you put here and the scale of your creation. So the other thing is this color. You can give it a swatch. You can type a color, like for example red, and just plop it here, and it turns red. You can remove it. It still works. You can remove the marker. Marker is the shape of the points, or let's say markers, put here, and there's a value drop down, and you can choose circle or triangle up or everything that there is in the library. We put it here, and we can just click and choose them. It's actually here in the draft, and you can pick the marker like this, and the marker style would be whatever you choose, like here, star.
Okay, sorry, Metin, sorry to interrupt you, because there's a
Yeah, sure.
considerably there is a delay between your voice and
Okay.
the yes, there. Can you please just try to share your screen again so to see if everything is
All
getting
right.
better?
Yeah, sure. Um,
Thank you. Thank you. Because you're
um,
explaining the each component in detail, and when we see the picture much
yeah,
later
sure.
than what you said, it is a bit confusing. And also, may I ask a favor
Sure.
if you can remove the stream gate in the that you input to the plottable, and just input
This
each
one?
plot directly to the, yeah, this one. This one.
Yeah, sure.
I think it's a bit confusing now that we are just
So,
explaining the
yes.
components. Yeah.
Okay. Okay.
And just
Yeah,
input
I get
each
it.
plot separately. Yeah.
So let's get rid of all of this. We don't need it.
Yes.
Um,
Yes,
this
that's
is the
good.
plottable.
Uh, I'm
This is the
sorry
plottable.
again. I just want to answer one question and then I will mute
Sure.
my voice. Well, the giraffe has not been released yet in the Food for Rhino. We will do this tomorrow. But for today, Alexander, you can just download the giraffe from the in the Google Drive. I have shared the link early in the morning in the Telegram group. If you have access to that, there is a Google Drive, and in that drive, there's a folder named Giraffe, and you can find the Giraffe and also the Javid plugin in that folder. And I explained in the group that all you need is to just download the Giraffe from that folder, unzip the zip file, and remember to unblock it before unzip the file, and then just drag and drop the whole components into the canvas. That's all you need to do.
I think also
Yes.
someone shared that link here in the chat.
Yeah, that's exactly my explanation in the group. Okay. Thank you so much. Sorry again, Martin. Sorry, we are
No, thank you for the explanation. Okay, let's go back. So here's the plot, and it's this component is called plotly, I think, or draft plot, and it might have either icons. I'm not sure which which one is the current icon. There's a difference between them, so I'm going to use a lovely component called a bifocal, so you can see the name and not get confused with the icons. So this is the plottable. This is out, so it will show warnings probably in the future, or some of the components show warnings, but we are currently just using the plottable. So if you just click and drag this plottable to that plottable, it's done. And the magic happens when you add more than one. So there's one here, and you can add another one and get a different plot that uses two of them. This is the reason we have divided this two into two different components. We could have had one component for doing all of that. It would be easier, of course, but it would not let us combine and mix and match and do stuff that we wanted to do. So, and these are alpha. Alpha, if you know the RGBA standard, alpha is determining how much transparent is a component in the picture. So if you put the alpha to 0, it's completely transparent. And if you put it on 1, which is 100%, it will be 100% opaque. And the label is actually the label of this plottable. So if you're making multiple plottables, you can give each one of them a separate label. So when you mix them or combine them, you can easily make out which one was the first one or which one was the one you were interested in. So let's carry on to the second one. Again, we have a populate, and there's no x, y, and z. You can use a construct point. Let me get the construct point here. Okay, and let's get a range. Get a range here. Maybe graph mapper. And use graph mapper as a graph type of parabola. And another one for z, and let's use a graph type of sine. Okay, so this one can actually replace this point because it's a point, obviously. And when we plot this, we see there's a probable line, but it's kind of faint. So I want to look at it from a different angle, and we need properties and the view now. So we go back to graph, we go to utilities, and there's a view here. We give the view, and we need an empty slider, and we need to put it as point of view. So this is a degree of azimuth and a latitude of the viewpoint. So we can change this to be from minus 180 to 180, and same goes for y domain. And we can start moving this around and seeing it from different angles. And maybe we don't want to build a construct point like this. We might want to graft it like here and get it like this. And let's graft this one as well. And it would be a line. And let's go back to the populate 3D so we can see a bunch of points populating this 3D scene. And we can see how they are plotted in 3D space and how we can use this and say maintain aspect ratio and double click it so it's 100%. And let's go back here. Again, we have size. It controls the size of the markers. We can increase that. And there's a swatch to control color. We can disconnect it. It will be red. And there is marker style, just like the one above. This is the same one, just in 3D, as you can imagine. And alpha does the same thing. You can make it faint or make it more prominent. And there's a label here. You can call it whatever you want. Let's call it M. You can see changes up here. And the other thing you need to remember, and it is very important, is that these numbers are representative of the data. These are not space representatives, because if you look closely, these are different. These are two different units. This is almost 25%, and this is two whole units, and they look probably 80% different, and they're not so much different. So it's representative of the data. So if the data is squished on one axis, it would not be reflected in the thing you see here. It will try to represent the data, not the space of actual points here. The next one is bar chart. So how does bar chart work? Well, we have a few things we need to talk about before we know what bar chart is. Bar chart has two things. One is a value, the other one is a label. You cannot just use any data to make that. Let's see, how does it look? Okay. So there's a label and there's an amount. If you have two amounts, or the amounts are not recurring or not the same, you cannot have a bar chart. If you have a lot of numbers, a bar chart would be hard to understand, but it would still work. And let's see what we have here. So there's a range and there's a graph mapper. So it creates a bunch of numbers. Let's see here. These are the values represented here. And the second one is actually the colors. So it goes to a graph mapper and gets a number, and it goes to it through a gradient. Then it gives out a RGB color, and the color gets plotted like here. And you can change the graph mapper, you can put different numbers, you can change the gradients, you can even have different swatches. Let's get a color swatch here and add another swatch. Let's make this red. And if you see, it uses the Grasshopper system of data matching. So the first one gets the first item, and the second one gets repeated till the end. So if you add a third one, let's say it's green. If I can make it, okay, this one is different. You can see it. So the first one is the first one, the second one is the second one, and the third one is the third one, and through the finish. So we usually need to use a gradient so that data match, and we don't have a recurring color. And you can actually have a width. You can change the width. For example, right here, we're using a graph mapper to dynamically change each one of them and give them different widths. So if you look closely, this one is thicker and this one is thinner. And you can use a float. Float is a type of number if you're not familiar with it. So a big number that has a lot of numbers after the point. So not 32.5 or something like that, is a float, and it works with it. You don't have to use a integer number. You can have any number. And if you look closely, you can see that the there's a pie chart. Let's go to pie chart. So pie chart can be two things, actually pie chart or a donut. They're made with the same component, just different properties right here. So the size is the value which you see here, and use a range right here. So it's a range of numbers, pretty self-explanatory. We give it to a graph mapper, so it looks like something is happening, and then it gets plotted as size. So if I change this graph mapper, you can see I'm changing the values right here. The other thing is labels. So how do we label this? And how do we make the labels? So if you take a look here, we are using a sublist of text, and we are picking 5 of them. So you can just block this off and say, for example, you want to add your name, and you want to add your friend's name. You want to add some random head bash, bunch of numbers and characters mixed up. You can do that and do a, let's say, you stop making it multi-line data, and this should match up. So this is 5. Let's give it this. And if they do match up, you get this. And it's fairly self-explanatory that you're labeling this here and you're labeling this again right here. So how do you remove this label? Maybe you don't want them. And let's go back to this type of label. And this first radius is the radius of this hole right here. You can increase it. It will start being more of a donut and more of a torus. And if you start to close it up, it would be a pie chart again. I'm hoping everyone is understanding everything I'm saying. I don't know. Everything's okay. No one has any questions. I'm just going through everything and chewing through the time. Is everything okay?
Yes, can I have a question?
Okay.
Yeah, can we change the style of the graph?
The what? I didn't
The
not
style.
understand what you said. The style.
Yes, I can answer that. Yes, in the folder of giraffe, there is a file, there is a GH file named example. This is exactly the example file that Martin is explaining for us.
Thank you.
Yeah.
So let's carry on. So if you have the radius set to 1, it's a pie chart. You increase it, it's a donut. And there is right here the PD stand. If you remove this property, you will put this at a different place. If you remove the label, you will remove. Pretty self-explanatory. Label distance not also controls the distance of the label, but also if you have a label. And donut right here is a different story. So we have a radius up here and a donut down here. Let's get rid of those. and see what happens if I move them through each other. Let's give it a 5.6. You can get this type of abomination. So it is kind of important to know which one is which and choose. Donut is this one, and it needs to be smaller than one, and this one is the radius, so it needs to be larger than one. It's important to be cautious of not making these the other way around. It would kind of mess up the whole aesthetic and kind of make it impossible to read. Let's carry on. Okay, let's delete this. And this is a heat map. So heat map is essentially a bitmap that you are creating with the data. It gets a data tree. Let's use a parent viewer and see what kind of data we have here. So it's a data with 5 branch, and each branch has 6 data inside it. So how this works is it gets each branch, and plots it as a row. So 5 branches, 5 rows, and 6 columns for 6 numbers for each of them. And it will try to fill up every cell that you have, and you don't have any numbers for it. So it's important to bear in mind that it needs to be a rectangular data. What I mean by rectangular data is you cannot have a branch shorter than another. How did we manage to make that? Well, we made a range. We added to graph mapper, so it looks like something's happening, just like all the other plots before. Then we added another one down here, and we multiplied them. So multiply 2 lists by each other. You get a list that is x times, if this is x, and y times that size. So for example, right here, this one has 4 steps, so 5. This one has 5 steps, so 6. And 5 times 6, so 30 data divided into 5 branches. Down here we have label. We're still using the same technique. We have a bunch of numbers, and we're cutting a list, that is list of fruits, with the number of rows we have here to get this label right here. And down here is the same one, just reversed, so it doesn't start with the same thing. This probably is familiar. So label is the y-axis and the categories is the x-axis. The only thing here that needs to be discussed further is here, the color map. So up to to this point, we had the ability to use any kind of RGBA color that Grasshopper creates, or we can name, or any type of other color creation method inside Grasshopper. This one needs a basic matplotlib color library. So we have a color library up here. You can choose any color from here, oranges or blues. You can see it changes color. And the reason is because you need to match the color to the exact number of this, and you need to make it a 30 for a 6x5 data type, and mixing and matching these are hard, and you might lose some colors, and the colors are indicators for you, so you might get a faulty graph. So we opted out to use this type of color and color library instead of the native colors of Grasshopper. And down here we have annotate, which shows the number which these colors represent. So if you look at here, 0.7 is the darkest color and it's the largest number, and this up here is too faint to see probably to the screen, but it's 0.2 and it's the faintest color up here. Let's change the, nope, not again, probably Inferno, yes. You can see the 0.2 is the darkest color and it's the, so this is just that number and that color being shown, and it's probably good for double checking if you're checking for any anomalies and you want to see the actual numbers. But if you have a big number, big data set, you probably would want to remove this annotate so it doesn't clog up the view and it's easily readable. The next one is Align 2D. So how do we make Align 2D? Let's start this one from scratch. Let's see how we make Align 2D. From up here, we have plots. And I come here, graph line 2D, and it asks me for a polyline. So why is it polyline? Same as before when we said we are using points, so user knows how to visualize it and how to get a good output out of it. This is the same reason. So if you give it a, for example, let's go up here and pick this populate 2D, bring it out here, and we can say, okay, we have a curve. I want a curve, put this here, vertices, and plot this in here, put the plottable up here. You get this jumbled mess of lines. So this is not informative. This does not show any data. This is not what we think you might want to use this for. You can use it for this type of data, but it's not going to be informative. So what we do is we ask you to make it a polyline so you are aware of what type of data you need to give it. So we get a range, and let's say 12. And the difference is 0.2. So we get a graph mapper for the y. And let's move this out of the way. We construct a point. And the reason we do all of this inside Grasshopper is because we believe people who are using this know how to use Grasshopper. They want to use Grasshopper. They do not want to create a cumbersome and different data management technique. And this lets it be easier to manage than a different data type. Let's choose parallel noise. And let's get it in there. So this is a polyline. If I get this out of the way and hide everything else, let's see where this is. So you can see this is a geometry inside Rhino, and you can also see it as a graph right here. Again, I'm going to emphasize on the fact that these lines should not be an indicative of space. You can see this. This is way shorter on the x-axis, but right here it is stretched because the amount of difference between these numbers are stretched. So this looks like a more of a rectangle, rectangle, but it's square-ish, and but the difference between numbers are not the same. That's the reason these two look different. Okay, so we know how to add a polyline to a graph 2D and now make it plottable. And we might need a label, so let's do that, and let's call it yo-yo. And let's label it with that. And you can see there's a label called yo-yo up here. And maybe we want to color it with a green. So again, I'm writing down green, just the words. We plop it here. It changes the color and the label with it. Let's change the width, 0.25. And the line space, the line style is right here. Graph, line style. I'll pick this and add this. So it's solid. And probably the width is too low, so I'm going to add 20. Yeah, this is too much. Style it back a bit. Okay. So this is solid. We have dotted. We have different types of it. So maybe densely dashed right here. And this is the kind of look you can expect from a line graph. So any kind of data, you can put that data into a construct point or a polyline and insert the polyline into the graph. So why not just use the polyline inside Rhino? So you will need this as a data. If you're working with data, you don't want the space like here. This is the space you see. But when you're working with data, usually you want the data to be spread out and you want the data to be represented. You can also mix and match these things together. You cannot do that just inside Rhino itself. And it would be cumbersome to do that. The only thing that we are doing here is reducing the feedback loop, as we said in the beginning. So if you start exporting this to, let's say, a graphical design software like Illustrator, you can make this inside Illustrator. It has a better graphical interface. You can make it a SVG or a different type of color. You can use all types of line types. But it would, again, make the feedback loop larger. And that's essentially undermining the whole ethos of creating this plugin. So let's go back here. So if you can look at here, it's kind of pixelated. Let's get into properties now. So properties up here, draft properties. Let's put it here. Insert properties, that. So we have a title. So it's the name of the thing that I'm working on. Let's call it line graph. And when I add it here, it would be added at the top here, just like you have seen Excel or other application. Title is usually up there. And X label or Y label right here will overwrite these. So if I say MA, something like that, and I put it here, it would be here and saying this is the unit, or let's say this is meters. So if you are showing the distance or calculating some perimeter and you want to put the actual unit down there, you can use X label or Y label. And if it's 3D plot, you can use the Z label. And this is the legend. So there's a legend location right here, and you can add it up here. So you see the legend is moving lower left, right, center, sometimes upper, depending on the data you have, you might need to move the legend, and this is how you do it. And two other things down here are probably the most important, so I'm gonna talk about them right now. This is ratio. So this is the aspect ratio of the width by the height. So you can do this, put width as a number slider and height as another number slider, and actually use a division and put this as ratio. So if you start reducing this or moving that, it will create the ratio based on what you entered here. And down here we have DPI, which, for example, for purpose of printing, you can use a 300 DPI, and it will look like this. You can increase it to any amount, almost infinity, but it would get extremely slow. So if you are using this for visualization and you are changing the parameters, please add it as default and do not increase the DPI. But if you are going to export it, you can increase the DPI, come here, right click it, and save as. The other two things down here are the transparencies. So if I put, let's say, 0.85 alpha here and reduce it to 0, it gets transparent and you can see behind of it. It might not look like much inside Grasshopper, but if you go back to Javid and you start using some other types of bitmap view, like billboard display, gets a bitmap and a point. So I'm going to put a point. Set 1 point. Let's come here, give it this point, and let's give it a size of 35. Let's see what happens. And so you can see in all of the viewports, you have a upright, always facing camera, a representation of this. So it is important to know what alpha controls. So if you lower alpha, it would be transparent, and if you increase it, it would be kind of faint, and it might improve legibility. And let's talk about hide patch. Well, hide patch is a Boolean type, so I'm going to use a Boolean toggle. If I give it false, nothing happens. If I turn true, it will hide actually the patch behind of your graph. So if you do this and reduce alpha, you can get a pretty cool representation of what you have inside Rhino itself. You can use other types of Javid components to do this, but this is basically what I use the most. So maybe other people who use it, we use different type of exports or different type of media to use it. If you're making a presentation sheet, you might want a completely transparent graph so you can put it whatever you want and not mess with the background or other elements inside your presentation. let's go back here. So let's delete all this. And this is line 3D. So just like line 2D, this is the same, probably. Everything is the same except one thing. What is that thing? Well, you have a polyline that is three-dimensional. Wow, really different, right? Let's plot this, and let's get a bitmap preview from our friend right here. Okay, so this is a bitmap preview. And you can see it looks like a helix. So how did that come to be? Well, it's a range. And when you added a sine wave to a range, it creates this. This is a sine. And let's get a view so we can look at it at other angles. Yep. And here, MD. Okay, slider. Okay, I missed the view. Okay, this one is the view. So let's edit this from minus 90 to 90. Copy that here. Okay, so from top, you can see the exact shape of this reflecting here. And if I give it back the Z and remove the Y, and I start looking at it from the side, you see exactly this graph mapper represented here. And if you do both, well, from this side, nothing happens. But from the perspective view, you see this kind of helix forming here. Kind of cool, right? And you can give it any type of data, like let's say populate 3D. And let's give that populate 3D to another polyline and add the polyline here. So you can see it creates a jumbled mess like we talked about, but it can do it. And we have dash dot here. We can add another one. So let's call this one solid. So for the second one, and let's do this. Let's call it blue, and I'd call it blue. So the second one, which was the jumbled mess, is now blue and solid. You can mix and match any type of data. Let's reduce the number of it. Count, yes, to 12. Maybe it will clean up. Yes. See, this is the jumbled mess. This is the helix. And you can mix and match, but be careful of what you are giving, as these are data trees. So when you are grafting one of them, you might fry everything you've done. For example, this is a one-time operation. It creates one bitmap. But if you graft any of this, I'm not going to do it because I'm presenting and it will crash my computer. But if I graft this right here, it will create another bitmap. But the problem is, when you have more than one, it will start to graft it across both of them, and it will create a cross reference. So if there's a 10 or 12 points here, and there's probably 50 points here, and you cross reference all of that together, you will create 10,000 bitmaps. That's not something you want to do, and that's not something your computer can do. Probably, I don't know what computer you're using, but probably you're not using a Google level of supercomputer, so you should not do that. You should be really careful with what kind of colors you input and the type of data they are and the data trees. And this one down here is just amazing. this one is a histogram. So histogram, just like a bar chart, shows data on two axes and divides them into beams. So what's the difference? Well, this beams is the difference. If you have a bunch of numbers and they're not the same, they're not labeled, and they are not from same category, so they are each individually unique. Uh, which one is the most recurring? None of them. They're all repeating at the same. This is 8.2, 8.1, 8, and they are all happening once. So it would be a flat line. So how do we make it different? This is something you have seen. So let's come here and talk about that. Let's add the bitmap. Right here. So there's 100 bins, and as you can see, it looks like it's an individual type of data, but it's not a stretch, it's binned. The importance of this bin is to give us a possibility of counting data. So if we cannot count anything, it would be all the same amount. So if I increase this bin, you can see it kind of goes to the same amount. But because there is eventually few bins, it will not be the same. And if I go back to, let's say, 50 or 60, you can see the trends pretty visually. And what is a histogram? Well, you probably have seen histogram inside Photoshop. Let's open Photoshop for a second. And since that is opening, I'm going to change this one to be red, like this. I'm not going to use this one. And let's open this one. So if you go to Window and Histogram, up here you're going to see the histogram of the colors used inside here, and you can mess with the histogram, probably move it around and see what's happening. And let's make it larger. Okay, I cannot make it larger, but you can see there's spikes here, and these represent the colors of the image you're seeing. The idea here was to create the same with this photo up here. I'm using a divide surface to create a grid. So I can give it a number slider of 20 by 20, and it's an image sampler. You probably have seen image sampler. And it gives me a list of numbers, and these are RGB numbers, so red, green, and blue numbers. And after that, there's an split ARGB, so it gives individual RGB values out. So let's look at this. This is R, and as I've said, these should represent the same number. You may be quick to point out this is 0.8 and this is 209, but this is from 256 numbers, and this is between a 0 and a 1. So this is a different type of domain, but they are the same number essentially. The domain is different. So what can you do after that? So remember here we started adding more. I'm going to start adding this as a new number and this as a new number. So we have three essentially overlapping data, and red, green and blue will be these, red, green, and let's say blue. So we're going to add this. We're going to add this. And we're not going to get what we wanted. Why? Because this is a different type of color. I forgot to mention that. Because we do not know how many, in creating a histogram, we do not create a different histogram for each one of those. We do not see a different representation of them. I need to graph them, and I'm not going to take that risk, and I'm not going to break my PC right here. You can risk it on your own. This is not the time for it. I might do it later on, but not right now. I'm going to disconnect these. So this is for red. Anything else gets disconnected. Green. And okay, so I'm going to do this. So this is only red. And right here, I'm going to get green and give green as the color and label. And do what? Do this. Now they are overlaid inside this plottable. This is the only thing that is good for this. So this plottable lets us plot different elements on top of each other. And let's use a swatch so we can do a transparent green. G, yes, and let's make it kind of transparent. So let's use this as color, and let's give it a red that is transparent. And you can see it kind of represents what we saw inside of Photoshop. And you're going to see more hands-on types of types of them, but for purposes of showing how data can be overlaid and how can it be used to make a histogram, this is what we came up with, to use a known histogram for everyone and use this to represent that known histogram. Let's go to the next plot, probably right here. And why did I remove the bitmap preview? Okay, again, maintain aspect ratio, double click to 100% it. Okay, this is a 3D surface, and you can see we have a point attractor that does this to remap a graph mapper and change the values of that, and remove the points up and down. We create a points surface from points, and we give it right here. So what can we do? We can delete all that, create a surface, and set one surface. Let's create let's close this up. Let's create a surface. Probably cone would be good. Let's go up here. Let's type cone. Sorry. Cone. And like this. Okay, this needs to go. So we can add it as a surface. Set one surface. This is a surface and it has UV direction. So we give it here. And as you can see, we have a surface that is represented by UV direction right here. So what is UV? You probably know how Rhino represents its shapes. It's a bunch of lines going in two directions, weaving together, and it's U and V. So it creates a mesh up here, and it's U times V polygons. So I can add more or reduce this V count. You cannot put it at 0, it will jump out, but 3 is good. And you can reduce this, and look at here, you can see the jagged edges right here. You can see the jagged edges right here. It's because the amount of division into a V direction is low. But I'm sorry, the amount of division in the U direction was low. So if I crank it up to something like 56, it will be smooth. And you can use any type of surface inside Rhino. You can create a point surface from point right here. Let me see, surface from points. Right here, surface from points, and you give it a bunch of points. Let's say we have, let's copy something we have here. Yeah, let's copy this. So this one needs to be grafted, and we're going to have this length, this, and probably we need to add a 1 to the end of it. Not sure what's happening. X minus 1. Okay, I'm not sure what's happening, but I probably can fix it. Let's do it as Param viewer. Okay, so it's 51. Let's see what we are getting. Okay, so it should work with 51. Let's remove this expression. Not sure what's happening. Okay, it's probably U count, so RVR. The other one, 51 by 51. Okay, because it's not flat. Yeah. 51. Okay. This is why I didn't do that, and because I'm not very careful with the data trees, and I might have actually ruined everything. So this is the surface. Let's plot it in here, and the V count is low, so we are gonna actually increase that. Let's get a view from graph here, graph view. Let's plot the view here, and MD slider again, minus 90 to 90. Okay, viewpoint, and let's move it right here, and you can see this is the dimension that we grafted, and this is X, and this is X as well. So this is how a grafted construct point will look like. And we can use any type of data like this to create a surface first, then plot the surface here, add UV, add a label, which is not present here. So let's put this here, and you can see the label up here. Again, color and edge color. This is the color of these edges of the mesh. You can see here, you can make it a different color, probably right here. You can see it's in orange, and you can increase or decrease the width of it. And let's delete this one. So this is probably good for most of things, and you can add a different surface to it, but remember to flatten it. Okay, probably one of them is too large, so I'm gonna divide this. Let's see, this one is here and this one goes there. So if I plot this, yeah, the problem is with the scales of them. So this is so much large that it dwarfs this one and then eats it up, so you cannot see it anymore. But the idea is still standing. So let's reduce the size of it. Maybe we can do this. And now we can see both of them together side by side, and you can move the viewport around so you can get a better view. So you can get a better view of how they look like together, and this is annotated as well. Now we know what plots do, how to choose between them, how to use them, how to manipulate them, how you can mix and match them. And probably I want to add this plottable here. Let's add this one. You can add any and all of them together, and it will just do it. It might not look like much, but you can do all of them together at the same time. I'm going to stop sharing my screen, and I'm going to take questions now. If you have any questions that I need to show on a screen, please open up your microphone and ask. If not, I'm going to stop sharing and you can ask me.
Thank you. Thank you, Martin. Thank you for your time and your effort on the presentation. It was really great. Thank you for introducing our Dear GF plugin. And if you can just take a look at the chat, we have a question. Of course, I should just say sorry to everyone that I know that we had a delay. I know the voice and the sharing video of Martin was not synced together. But this is out of our hands. It is because of we are in different time zone. Everyone in this workshop, they're coming from different time zones. So it is something that we should just deal with it. And thank you, Mai, for your really great tips here. Mai said if we open the YouTube in another tab and use with a voice and another with video, like we can follow the video from the Zoom and follow the voice from YouTube, and you don't see any delay in voice in YouTube. That's something new for me. So
That's a
maybe
lot
if
of
you
hoops
just
to jump through to get them syncing. Uh, okay,
yeah.
so the error is called, his name is Mahdi, right? Matt is getting the error is for the problem is with this installation of Matplotlib, and you either don't have it or you have installed it wrong. So there's two types of command you can use to install a library right now on Grasshopper. You can either use the Python inside Grasshopper to use the package manager inside of it, use Nugget or pip install inside of that. For matplotlib, it works flawlessly. Just use that. Do not use any other types of installation method. Do not use the hash r's or system command line. Use the built-in installer for installing the libraries. Then it will be resolved. If you
Thank you,
still
Martin.
have
Thank you,
problem with that,
Fatima.
you need to
Yeah,
you
sorry.
need to delete Rhino code and do this. Do the steps as I said. Go to a Python component, open the library manager, pick pip installer, and type in matplotlib.
Thank you. Thank you for your explanation, Martin. Thank you for your tips, Fatima. But before going for those a bit of complex results, could you please just let us know that if you're using Windows or you're on Mac, and just again, could you please check if your Rhino is updated to the last version? Maybe these two just simply can solve the problem. And also, please consider a reinstall because for now, our plugins code is inside the components. We have not made a library out of it yet. So we will have a little, we expect a little of these bugs in installing the libraries that we need. But for now, just let us know if you're using Windows or Mac, and then if can you check, please, that your Rhino is updated to the last version and last thing. And okay, Mahdi answer us. He's on Windows and he have just installed the latest version of the Rhino to be sure. Okay. So then again, I want to have another simple tips. Can you just go for a restart after in our rest because we're going to have a 10 minutes rest and then we'll get back to other giraffe teams. They're explaining like 5-10 minutes each one for their projects that they do with giraffe. So in our rest time, Mahdi, would you please go for a restart your laptop or your PC and try again to see if it is solved. Because if it is not solved, then you should go to the next level that Matin and Fatima mentioned. You need to install the library yourself and just we will go to see what we can do on our plugin not to have those problems again. And also, yes, might give us another simple tips. Did you unblock the zip before the unzip? You know, when you download the zip, before unzip it, before open it, before doing anything, when you download the file, just right click, go to the properties and check that it is unblocked. So it can go as a charm, I think, like it goes for others. So thank you for staying with us. These all long, and let's go for a 10 minutes break, rest, coffee, and anything, and then we will get back in 10 minutes to see how the other giraffe teams use the giraffe plugins and components in their own projects. Thank you, everyone. See you in 10 minutes.